Hi, I'm Darren and welcome to Level Up Double E Lab. Once again, I've taken apart my HF transmitter, which can only mean one thing. I've been working on those modifications I was talking about. Let's see how far I've gotten. I could not wait. I jumped ahead and I made the modifications to the top and bottom channels of the rig to accommodate the modified cover. First, I removed the top channel, made the cuts that I needed right here, then reinstalled it, and then repeated the process on the bottom channel, made the cuts that I needed, and then reinstalled it. It's more work that way, but that kept the whole rig from falling apart in the meantime. And ta-da! It fits nicely, just like I wanted. It's in here securely. It's really easy to remove. So I can get in here and get to that filter. And this filter, the bandpass filter and the low pass filter, replace them, put the cover back on, pop it in place, and I'm back in business. So moving on, next item, the keyboard for sending CW. Now I said in the prior video I was not going to use this old USB keyboard. I had several reasons why I wasn't going to use it, and instead I'm going to use a PS2 style QWERTY keyboard. That PS2 interface opens up a lot of options, but I did not particularly want to use a full-size keyboard like this one. The main reason being, well, it's just too big. If you look at the size comparison here between my receiver and the transmitter, it just takes up even more space on my desktop or on the workbench, and it's got features that I really don't need. And clearly, a full-size keyboard is meant for typing essays and emails and a whole bunch of other stuff. So I want a smaller one. Now, I could have scoured Hamfest or eBay to find a smaller one, but I splurged a bit for this project and I bought a new one. This guy right here. First of all, this is absolutely adorable. Look at it. It's so cute, so small. It's 9 inches wide or 22 centimeters, so it's about half the size of a full-size keyboard, but it is still fully functional. It's got even function keys up here at the top that I can program for macros and such for sending CW. So that's nice. And any smaller, well, it probably would be just too small for my hands. So just for perspective, I'm about 6'1", and my hands are just big enough to grip a basketball, and they can span the whole width of this keyboard. I'm going to be hunt and peck typing on this. Clearly not going to be writing lengthy CW communications on it. So hunt and peck is fine. So I think this is going to work out great. And the size obviously fits in very nice with the scale of the receiver and the transmitter. Since it's a new one, it is native USB. So naturally, you need an adapter. One of these guys. Well, these guys, I'm sure, have been around for quite a while. So this will convert USB to the miniature DIN 6 connector needed for the PS2 interface. Then that leads to the next question. Where am I going to install it? I'm going to have to put this guy on the rig somewhere. This is the miniature 6-pin jack. Doesn't take up much space, but I don't have that much space to give it. So my options are kind of limited. Obviously not going to put it on the side panel that's removable. I'm not going to put it over here because there's actually 2 layers of aluminum here inside the rig. So that leaves, of course, right here, roughly on the front panel, or maybe someplace around here on the back panel, or maybe squeeze it in up here between the 2 antenna jacks. It's going to be a little tricky because I don't have that much room in either case, because back here, well, I've got the 2 power supplies and there's not that much space between them and the back panel. And then on the front, I've got the controls, plus there are 3 printed circuit boards stacked right there, so not much space. So I'm going to give that some more thought before I make a final decision on where to put that jack. I gave this some more thought. I even took apart the rig so I could have a closer look at the space available on the front panel and the rear panel, and I had a flash of brilliance. I'm only using 5 of the 8 pins on the existing GX16 connector here on the rear panel. 12 volts, ground, RS-232 transmit, and RS-232 receive, which all continue on over to a similar connector here on the receiver. And then the 5th one is a breakout that goes to my straight key so I can send CW. And this is the crude cable that I fabbed up to interconnect them. So what if I use those open 3 pins for the 5 volts, clock, and the data signals for the keyboard? I already have a ground, so that completes the 4 that I need. And therefore, I don't need to find a space on the front or the rear panel to package this little mini DIN socket. To do this, I could make a new breakout cable, but that would be even cruder and even uglier to have another thing hanging out here. So instead, I'm going to build a dongle, a short segment of cable that goes into a small box that then breaks out to the PS2 jack, a connector for my straight key, and then the cable that continues onto the receiver. I certainly could use an off-the-shelf project box like one of these, this aluminum one, or this plastic one. Unfortunately, I don't happen to have one on hand right now large enough to have all three of those breakouts be on one side. So I'd have to do something like the cable from the transmitter coming in here, and then the other three guys around here. This would make like a star shape. I'm not crazy about that. In fact, I don't like that idea at all. So I've designed my own box that I'll 3D print. Here's what I came up with. It's a simple box with a simple cover. Size-wise, it's 40 millimeters by 80 millimeters by 33 millimeters tall, and I sized it just long enough to let me put the three breakout connectors in a row on one side. Entering this face will be a short length of 8 conductor cable coming from the GX16 on the rig. Then on the opposite face are the 3 breakout connectors. Left to right will be the DIN 6 for the keyboard, an 8-pin GX16 to continue on to the receiver, and then an 1/8-inch phono jack for my straight key. Inside will be just the necessary wire connections. I don't need a circuit board or any terminal strips, and then it all gets covered up with a lid held on with a pair of number 6 screws. Note that I've included several anti-turn features here, like this hexagon wall for the strain relief and flats on the hole for the GX16. That'll help these resist twisting torque better. Here's the box with a couple of the connectors temporarily installed, and here's the cover. It goes on top. Pretty simple solution. I like it. And on this side, this is where the cable will come in from the transmitter. There's that hexagon shape feature I was just describing. And the strain relief fits inside there like so. So it can't turn when I'm tightening up the nut here on the inside. I've got enough room, I think, to route the wires and to do the soldering. I will need to splice together the ground wires, but everything else is just going to be basically point to point. Now, because this is plastic, I won't get the shielding benefits of an aluminum or a metal box, but I'm not sending any RF energy through here. My RS-232 and PS2 baud rates are very low, so I should be okay. If not, well, then I'll try something else. All right, I finished the assembly of the dongle, and it turned out nice. So let's walk through it. This foot or so of cable sticking out this face with this nice strain relief right here. This is the end that'll connect up to the transmitter, and because these connectors are keyed, I aligned this so that when it's plugged in to the transmitter, the box is going to be oriented like that. Now, ordinarily, I've got the transmitter standing vertically, which means the dongle is then going to be laying like this on my desktop. So it'll be nice and flat the way that I want it. Now, doing the soldering inside was a bit tight, and I'll show what the interior looked like before I put the cover on. And for those like me who've done 3D design for a while, you appreciate pretty quickly just how much larger everything always looks on the screen, and this guy was no exception. If I'd made this any smaller, I would have really struggled with my fingers to get in here and make the connections. As it was, I used some needle nose pliers to help position things, and that really was necessary in order to get all the connections made up. And I have checked it on my DMM, including all the other cables here, and all the polarities and circuits check out fine. So I did a good job, I think, soldering it. Let's talk about the connectors here real quick. That's the 2.5 millimeter miniature audio. I'm using that for my straight key. It'll plug in right there. Now, ordinarily, I would have had a 1/4 inch plug on this cable, but I'm going to have to use this adapter for my older rigs that need that size connector. I'm not going to keep cutting this off and putting a new one. I'm just going to use an adapter. The middle connector, obviously, is what continues the circuits on over to the receiver. There's only 4 of them. There's 12 volts ground, and then the 2 RS-232s that transmit and they receive. And there's a couple ways I could have done this, but what I decided to do is make this as a crossover cable. So the transmit on one end connects to the receive on the other. I could have done the swap in either this connector or this connector, but I figured, I'll just do it as a crossover cable. And either way, it doesn't matter which end I plug into the receiver and which end of the dongle. I can reverse them and it's still going to work just fine. Last one, of course, the whole reason for this whole project is to get this PS2 jack so that I can interface it with the transmitter. So there it is. Here's the adapter. I can plug it in and then plug that keyboard I was showing earlier right into it. Or if I do pick up a PS2 keyboard in the future, I can plug it in directly as well. So this is all good. It's all done. This bit of hardware is ready to go. Yeah, a dongle may not be an elegant solution, but it certainly is a functional solution. And in this case, it saved me from having to hack up the front or the rear panel on my HF transmitter to add another connector. Okay, so looking ahead, what's next? Well, I have several more episodes planned to cover all these modifications. First of all, I did get the boards for both my new RF preamp and a new main board design that I ended up drawing to accommodate the Nano Every that I'm going to be using and all the other changes. So a lot to do here to populate these and test them out. Plus, I have been working on the software updates, which have turned out to be a lot more extensive than I thought they'd be. So there probably will be a whole episode just on the software by itself. So plenty of things happening on this continuing HF transmitter project. As always, I hope you guys are enjoying my content here on my channel and enjoying this specific project. So until next time, bye for now.